Welcome to Spring LIB.
Okay, in this problem we have electrons organized in an equilateral triangle where the length between each electron pair is known, and we're asked to find the total work required to assemble these electrons in the current configuration. So to do this, imagine moving the electrons in one at a time to their present locations. The first electron we can move into its position for free because we assume that there are no other charges there, and so there's no electric field and nothing to resist moving the electron to that position. Once we move this second electron, we assume that it's in the electric field of the first electron, and so we can imagine moving it in on a line from until its present location. So one way of doing that, computing the work, is to simply multiply the charge of the electron times the total potential difference it moves through to move it to its current position when there's one existing electron already there. So if we do Q V12 and plug in the relevant quantities, if we assume that we bring the electron in from infinity, where V is 0, assumed as V 0, the potential difference will simply be the potential due to the point charge at the distance away, which would be this quantity. So with simplifying it down, the work needed to move the second charge into position is 1 over 4 pi epsilon naught E squared over L, where this is simply the length. All right, now to move the third particle into position, we imagine moving it in from infinity, and it's in the field of the two existing charges now that the charge 1 and charge 2 are already in place. So our work term will involve the charge of the particle multiplied by the potential due to 1 on 3, and the potential due to 2 on 3. So we will have two terms. You have our negative E, you have our negative 1 over 4 pi epsilon naught E over L, and a second 1 over 4 pi epsilon naught E over L. This is the potential field due to each of the now static charges sitting in place. Adding this all together, we have 1 over 4 pi epsilon naught 2e squared over L. Okay, and the total work required to assemble this entire configuration is simply the work to move each individual charge into place, which becomes increasingly difficult as more and more is stacked in place. So the first one's free, so that requires no work. We have the second one, 4 pi epsilon naught, 1 over 4 pi epsilon naught E over L, E squared over L, rather, plus 1 over 4 pi epsilon naught 2e squared over L, which simplifies down to 1 over 4 pi epsilon naught, always the recurring player, 3e squared over L. All right, and when we plug in values for E, the electron charge, and for L, which is given to us, we will end up with about 6.9 times 10 to the negative 18 joules, which is about negative 13, or rather 43 electron volts. And that's it.